All right, for our second videos for our video for 2.4, we're still using elimination, but for our next two examples, we're actually asked to solve the system using our method of our choice. So we can actually use graphing, substitution, or elimination. Okay, so for example 4, if we're looking at these two equations or this system, we have our first equation being 4x minus y equals 3, and our second one being y equals 6x minus 7. Now before we start looking at this one, I want to give you a little hint on when to use which of our methods. Okay, so if you want to write this down somewhere, kind of off on the side on your notes, this might be helpful when we're going through some problems or going over some of the homework, and you're asked to solve using your favorite method. Okay, now again, if one method for you just always works better than another, it's okay to always go to that method. Okay, that is just fine. For myself, I have found it's usually easiest to go to graphing. So I would say use graphing anytime where both of your equations are in slope-intercept form, or we have it as y equals something times x plus something. Or if it's really easy to get there. If you can get both equations to this slope-intercept form really, really easy, then it'd be really, really easy to graph them. So that would be a case where graphing would be very easy or very good to have. Okay. When I would use substitution is when I have either x or y alone. Okay. So it doesn't necessarily matter which one, x or y, but if I have x equals something or I got y equals something for at least one of my equations, then it'd be really, really easy to substitute that in to our other piece. Lastly, elimination is probably the method that you'll go to very last. If you're looking at your equations and it's not easy to graph them, or it's not easy to use one and substitute it in for the other, that's when you would use your elimination method. So going back to our system then, if we have 4x minus y equals 3, well, already we can see with this one, it's probably not so easy to graph that because we don't have a y equals mx plus b. So in this case, I would say don't graph because that one is not something, not an easy one to graph. So we can kind of cross that one out. We know we're not going to be using graphing. So we'll look at, do we want to use substitution or elimination? Well, in this case, looking at our bottom one, we already have y alone. We'd say y equals this amount, 6x minus 7. Since we already have y alone, substitution is probably going to be our best choice here. So this would be a real good example, a real good situation of when it's real easy to substitute. So in this case, again, I know we're in the elimination section, but we're actually going to use substitution just because this one is already set so easy for us. So if I'm using substitution and I'm plugging in this piece every time I see y, I go back to my top equation, this one over here, and I say instead of 4x minus y equals 3, I say 4x minus 6x minus 7. That amount, this whole chunk, is being plugged in. So 4x minus 6x minus 7 equals 3. Now again, remember, this minus outside here, this piece out front, is like we're taking negative 1 times each of these pieces, because it's like distributing. So you have to make sure that you keep everything together. So when we're simplifying this piece, it'll come out to 4x plus negative 6x plus positive 7. This was a minus 7 or a negative 7, but because we had this times the negative 1, or because we're subtracting it, it's like saying subtracting a negative 7, so we're actually adding it. So it became 4x plus negative 6x plus 7 equals 3. Combining our like terms, our x terms, 4x and negative 6x became negative 2x. Still adding on that 7 equals 3. We're going to subtract 7 from both sides. Get rid of this piece. That's going to leave us with negative 2x equals negative 4, because 3 minus 7 is negative 4. And then to get rid of this negative 2, I have to divide by negative 2, oops, on both sides. So this side too, negative 2. When I do that, we get x alone equals positive 2. So we've solved for x. Again, this time we're using substitution. You can use any of the methods you want, any one of them, but now that we know one piece, we have to plug it back into one of our equations. Again, you could have used the top one, that's fine. You could have plugged it into this equation. I just happened to choose the bottom equation, so I'd say y equals, instead of 6x, it's y equals 6 times 2, and then minus 7. 6 times 2 is 12, so y equals 12 minus 7. 12 minus 7 is 5. So the y value of our solution is 5, the x value is 2. So we'd say 2, 5 is the part where, or the point where both of these graphs will cross through. So that is our solution. It's the one single point where they will both be at. If we were to graph this, if we wanted to solve it by graphing, we would, again, notice that both lines go through the point 2, 5. If we were to use elimination right away, we would have to kind of move things around. But if we were to eliminate, we'd get the same answer here, 2 and 5. Oh, so this was our table of when to use which piece. Our last example then, solve the system using the method of your choice. Again, we want to look at what would be easiest here, graphing, substitution, or elimination. Now again, in this case, we'd say probably not graphing because we don't have anything in a y equals mx plus b. In this case, we probably won't use substitution, again, because we don't have x equals something, we don't have y equals something. We have kind of a little more difficult, a little more complex equations to work with. We've got x and y's on the same side together, so we don't have anything alone. So in this case, we'll probably have to use elimination. That seems like the best bet. If we're using elimination, again, we need to look at trying to get my x values opposite of each other or my y values opposite of each other. Okay? Now, x values, I've got positive 8x and negative 3x, so those are not opposite of each other. Y values, I've got negative 2y and negative 2y, so they're the same number, but they're not quite the same, or should I say the opposite value of each other. If they're both negative 2, we need one of them to be a positive 2. So as I'm changing things around, I'm going to multiply that bottom equation by negative 1. Or in a way, it's kind of like thinking, I'm taking this top equation here and subtracting this equation. If I subtract this whole equation, remember, it's like applying this negative in front of everything. So this becomes plus, this becomes positive, this becomes minus. Okay? If I were to kind of subtract everything, it's the same as saying negative 1 times it. So the top one doesn't actually change. It just stays as 8x plus negative 2y. I changed this minus 2y into being an add negative 2y, just because I think it's easier to add things and kind of think of it as being adding a negative 2y equals negative 6. My bottom equation then, because I'm multiplying everything by negative 1, it becomes a positive 3x plus a positive 2y equals negative 27. Okay, now when I look at all my pieces, my x terms, they don't necessarily match up. They're not positive and negative, or should I say they're not opposite of each other, but my y terms are. We have a negative 2y and a positive 2y. Okay, since they are opposite of each other, they'll cancel out, or they will eliminate. Okay, that's our goal for elimination. So I just add everything up then. 8x and 3x becomes 11x. Negative 2y and positive 2y become this 0y. Or again, essentially they're just eliminated. We got rid of them. Negative 6 and negative 27, we add those together and we get negative 33. Okay, so at this point we can say, or kind of simplify our equation. to 11x equals negative 33. Like before, if we want to get our x alone, we're going to have to divide out that coefficient, divide away the 11 from both sides of our equation. Whatever you do on one side, you have to do to the other, which leaves us with x equals negative 3. So we got x all alone. Just like before, take that x value, plug it into one of our equations. Doesn't matter which one, I happen to use the top. So instead of 8 times x, I'm now using 8 times negative 3 plus that negative 2y equals negative 6. Again, I changed this minus 2y to say plus negative 2y, just because I think it's easier to keep things together like that. I'm adding on negative 2 times that y value. Simplifying things out, 8 times negative 3 is negative 24. Still added on to negative 2y equals negative 6. If I want to get rid of that constant term, that means I want to add 24 to both sides of my equation. Okay, that'll cross that piece out. So we'll just have y's alone. It's going to leave me with negative 2y plus positive 18. Okay, because I added on the constant to both sides. Now, I've got negative 2 times y equals 18, and I want y alone. So in this case, I'm dividing by negative 2 on both sides. When I do that, that's going to get rid of this piece, so we'll just have y alone. Oops. I have 2 of that. Okay. Y would be all alone. 18 divided by negative 2, well, a positive divided by a negative is going to be negative. Oops. Lost my negative term there, or negative sign. 18 divided by 2 is 9, so y equals negative 9. Putting everything together then, we would say the solution is at negative 3, negative 9. Again, you can graph it, you can use substitution. Those ones just might be a little bit more tricky. Or you can use this elimination. No matter what, you'll find out that these two lines, or these two equations, they cross at the same point, negative 3, negative 9.